Welcome to Brain Vision.
Question number 95 is a wave function question, which gives you two equations, one equation for the wave function of the 1s orbital, and one equation for the wave function of the 2s orbital. These equations show you the probability of an electron being found at a particular distance from the nucleus. The two equations that are provided are these two here. This first one, where this is pi, and I've just written in 3.14. This is A naught, or alpha naught, which they gave to us as 53 picometers. And then this is also A naught, which is 53 picometers. And then down here, this was 1 over 32 times pi. 32 times pi is 100. And then this is 1 over a to the 3 halves. And then this is 2 minus r over a, or alpha naught, which is 53. And this is e, or exponent, to the negative r over alpha naught, which is 53. So if we take these two equations and plug them into an Excel file, I'm using Excel here as a spreadsheet, then we have this equation here, which, let's see, well, it didn't increase the equation size. What I did is I plugged in the equation into Excel by doing equals, and then all of the information that was found in the wave function for the 1s orbital, and then the same thing, slightly different, up here for the equation of for the wave function of the 2s orbital. And where r was, I just put in C2, and then I have over here r. So we're starting with 0 and going all the way to 200. Then what I can do is I can just grab the corner of this and drag it all the way down, and you will notice that it will change from C2 to C3 to C4 to C5 to C6, so that I get the correct R value for all of the calculations. Then what I do is I highlight the graphs that I want, or I highlight with a control or command on a Mac the two columns that I want to plot, and then I go to Insert, Chart, Scatter Plot. XY scatter is the best, and then it plots it for me. Turns out that it plotted the X here and the Y here. So if I right click and I go select data, I can simply swap my X and Y values, which is what I did to get this graph here. You'll see that this ends up going down to 0, but not going beyond 0. Well, it doesn't quite go to 0. If we look at the actual data, it gets smaller and smaller, but never goes to 0. But the data for the 2s goes to 0 and then begins to go negative. As it goes to negative, goes to 0, we then end up having a node right here at 0, which can be seen in our graphs with our second one. We see it crossing the x-axis. This would then be our node that was requested for the 2s wave function. You get the general appearance of these two graphs by plugging in picometers here but to get the actual numerical values, we should probably put in 53 times 10 to the negative 12, so that we would get actual picometers in our equation. But the general appearance would stay the same. It's just that these numbers would be different from what we've calculated. So we see a node with the 2s and no node with the 1s.